Hello everyone, I'd like to walk you through my project of graph visualization. Let's start off by uploading a data file. The tool supports multiple file formats including JSON, SIF and CSV. Right now I'm currently beginning with uploading a JSON file. As you can see, the system now processes the file. Let's upload the data. As you can see, the system processed the file and generated a graph accordingly. We can also query different subgraphes and return nodes along with their direct connections. Let's say we want to query the subgraph of Elon Musk. I'll select Elon Musk and let's go. As you can see, the graph has been generated. We can also generate multiple subgraphs of different nodes which are separated by a comma. Let's say we want to generate for Elon Musk and Jeff Bezos. We query the graph, and Jeff Bezos with his graph is generated over here. Additionally, we also provide different layouts for visualization. We have grid. Let's apply it. We have circle. We have concentric. These are various layout options that we provide. Along with this, the system also supports the streaming and chunk based parsing. Now let's upload a massive data set to see how effectively it generates the graph. Let's upload it. As you can see, this file is being processed by the system. um, let's wait for a second. As you can see, a massive graph has been generated. Let's query the subgraph of node 1 and choose grid layout. As you can see, these are all the different graphs, all the different direct connections of node 1. This data was got by Stanford University. The link to that will be provided. Now I would like to describe the JavaScript code of the project. We start off by declaring the global variables which will help in storing the graph data, and CY is the instance of the cytoscape which we have created in the project. We have created a function to display the errors effectively to the user in the front end. Then we have a function that support called as upload data, which basically takes the files which is uploaded by the user, and if there's no file, it displays an error which is no file, and it starts with processing the file. Then we have it segregates it into different sections. That, let's say, if it's a SIF file, if it's a JSON file, if it's a CSV file, we use a separate function for each of them, that is parse SIF, parse JSON, parse CSV. And if no file is if the file does not support the given format, it displays an error for the same. Then once the file is being parsed and all the data elements are recovered from the data, we then parse promise, which is essentially asynchronous and returns a knowledge graph, which is then displayed in the front end. Let's start off. Next we have parse CSV stream, which is basically used to parse the CSV files that are provided by the user. It starts off with by reading streams to effectively handle the large data, and we have a text decoder which basically converts binary to text data. Then again we have a promise and entity set, which is basically a set of nodes and relations, which essentially is the edges of each of these nodes. We process the data by chunks and to effectively handle the graph, as I already mentioned. And from each of this is recursively called to unless it is done. If it's done, then it stores the entities inside it stores the nodes inside the entities, and the relations, which are basically basically the edges of the nodes, are then passed on to resolve. We have a buffer to store the buffer values, and we skip all the extra lines which are essentially empty, and then we pop them off. For each line, we split it into different tokens and trim it down, and we add the source into the entity set and target into the entity set, which are the nodes, and define the relation. Similarly, we also have a SIF streaming function, which basically does the same thing, but just supports the SIF. And similarly, we have a JSON stream which provides a edge, target, and the type. Finally, we have a render function which displays an error if there is no file or no format found. Then we have then we basically pass it on to the render. We take the nodes and the edges from the knowledge graph which we already had created in the start, and it passes them on to the render graph function. The render graph function then uses the cytoscape instance that we created and stores them inside separate nodes and edges for each of these node and edges that we passed on. We also have a query subgraph function which essentially queries all the subgraphs that we want to generate. Like in the video, I created a subgraph of Elon Musk. This takes the input from the user and queries it into different for each of these input. We uh, we edit the knowledge graph that we had already created and create a new subgraph node with them, and use the edges and push the edges that are connected by that node itself. And finally, we render the node and the new nodes and new edges that are created by this function from the render graph function again. And finally, we have an apply layout which supports different type of layout options that are available in the front end, and these are just to call them. Thank you.